Oh, morning. We are on 13.2, page 744. All right. By now we lost them, though. Well, their books are there. How's it going? Good?
Oh, good.
Okay, good. We are forging on through chapter 13. We may or may not be doing something different tomorrow. Miss Morell is gone for 2 days, so I'm not sure how that's affecting our some of you math support people are okay. Somebody to read for us, please. Top of page 744. Jerry, start us. Looks like we got a lot today.
In a previous lesson, you determined what is the translate, rotate, or double figure. The resulting image is the same size and same shape as the congruent. Therefore, the image of the congruent is congruent. Recall that congruent line segments are line segments that have the same length. Congruent triangles are triangles that have the same size and the same shape. If the length of the line segment AB is equal to the length of line segment DE, the relationship can be expressed using symbols.
Okay, here's some of the symbols. One way to symbolize it is A equals DE. That you're usually talking about the length. Another way to symbolize it is with that M in front. That M means measure of segment AD. Notice it has a line. So this is the distance between A and B equals the distance between D and E. This is the measure of the two line segments are equal. And then this one is congruent. It looks like an equal sign with a little squiggle over the top. Okay, you've seen these before. This is kind of vocabulary. Christopher Bernal, could you read about congruent angles?
If the measure of angle A is equal to the measure of angle B, the relationship can be expressed using symbols.
Okay, so same kind of thing, but with angles. One way that it is expressed is with a little M in front of the angle. Then you see how it has an equals. Another way it's expressed is with the congruent sign. Notice that the congruent sign does not have the M. You're talking about congruent means if I cut one out, like our little trapezoid was cut out, and put it on top of the other, they would exactly match. They would line up equal size. Okay? Graph triangle ABC by plotting these points. Go ahead and plot the points, my friends. Graph triangle ABCD by plotting these points. Classify triangle ABC. Explain your reasoning. There's this one, so Brody can see it already. This is a right triangle. But one of the things to talk about that I'm not sure if they're expecting you to know it from other years, but acute and obtuse. Those are ways to describe angles. They're also ways to describe triangles. What does acute mean?
Less than 90 degrees.
And what does obtuse mean? Okay, so this is like cute. It's small and cute. This is obtuse. This is like it's a beast. It's big. Okay, so acute and obtuse. If you have an acute triangle, all of the angles are less than 90 degrees. Here, let's see. There we go. That's probably an acute triangle. Okay, every single angle less than 90, acute. So, obtuse has one big angle in it somewhere. They can't all be big. They have to add up to 180 eventually. If you had them all big, then they'd never come back together. Okay, you need some small ones, but obtuse has one big one. So a lot of times when they say classify a triangle, they want you to say either that it's acute, obtuse, or right. Okay, use Pythagorean theorem to determine the length of AB. Okay, length of AB. So first of all, what's the length of AC? That one's straight up and down. We can count it. Jerry says it's 8. Count the boxes. Verify. Is Jerry on it? Chris V's shaking his head. 8. What's the length of BC?
7.
Was that a guess? Or did you count? 7. Okay, so they want us to find this, and we can't count boxes because it's on a diagonal, so we have to Pythagorean it. Do you guys have calculators? There's some more over here. I can see probably some people do, some people don't. Here we go. A squared plus B squared. Okay. Who has an answer for us? What's C?
$10.63 or 10.6.
Do you agree with him?
Yeah.
That sounds about right. The hypotenuse is always larger than either of the two legs. It's the longest side in any triangle. And these all look about the same ballpark. So 7, 8, and a little over 10 sounds good. Translate the triangle 10 units to the left to form triangle DEF. Graph triangle DEF, list coordinates of the points DEF. So 10 units to the left, each corner we go and count 10 boxes over and make a new dot. Okay, 1, 2. And I'm going to make the D correspond to A because that's smallest in the alphabet or first in the alphabet. I'm going to go alphabetical order, so I'm going to make the B be E. So just like it went A, B, C, I'm going to go D, E, and then this one's going to be F. And it was straight down right here, F. Oh, you can't see it. So again, alphabetical order with the corners, A, B, C, D, E, F. I kind of made them match up, similar vertexes. Okay, we need coordinates. D is 2 to the left and 10 up. 2 to the left and 10 up. E is Here's negative 8, so that looks like negative 9. And 2 up. And F is negative 2. 2 up. Are you with me so far? Flip the page. Corresponding sides. Somebody to read. Brody, did you want to read before? Seemed like there was a bunch of people.
Corresponding sides are sides that have the same related positions and corresponding geometric figures. Triangle ABC and triangle BEF in question 1 are the same size and the same shape. Each side of triangle ABC matches or corresponds to a specific side of triangle B.
So I made a point of going in alphabetical order so that the letters correspond. The A, which is first in the alphabet, corresponded on the same spot on the triangle as the D, which is the first letter in the alphabet. That's what we're talking about. The pieces that match up. Given what you know about corresponding sides of congruent triangles, predict the side lengths of triangle DEF. What do we predict? Okay, so let's go, let's just look at the picture for this prediction. I've got side DF right here that corresponds to side AC. What would I predict is the length of DF? Even before we count, we can predict that the corresponding side is 8. Because what did we do to create this triangle?
We moved it.
We just moved it. We translated it. And if we translated right, we should have translated all pieces the same amount. Everything was supposed to slide 10. In that case, it would all be the same length. So BC is a corresponding side to EF. What should be its length? What should this guy's length be? 7, because this side matches in shape and position this side of this triangle. Those are the corresponding sides. We can predict the length will be the same. Okay, what's the last 2 corresponding sides?
10.6.
10.6 was right here.
And 8 was on the other side.
Okay, where does that go, Christian, on the other triangle?
Hold up. I'll put pencil. I'll get them one. I don't know pencil off.
There we go. Okay, so here's what I was asking you, Christian. See this side AB? What side on the other triangle does it correspond to? DE. And so if this is 10.6, what do we expect that length to be? 10.6. Okay, flip back. Oh, no, wait, where were we? Yeah. Okay, so we were on number 3. Identify the pair of corresponding sides, determine the lengths, compare the lengths, blah. Okay, let's identify the corresponding sides, but I'm not sure. Some of this, they want you to prove what kind of looks pretty darn obvious. That's part of what math is about, but let's look at this. So we have side AB that corresponds or is congruent to, what's the side that side AB is congruent to? You guys look at your triangles. I don't want to flip back and forth. What do we got? D, E. And then we have side BC. What side of the other triangle does that correspond to? EF. And then we have side AC corresponds to side DF. Okay, so we looked at them on the picture just a minute ago. Here's how you would identify them. And you're being careful as you write the name of AB that whatever order these letters are in, A first, B second, the corresponding vertices or corners of the triangle have to be in the same order over here. That's a convention for math. Fast forward, fast forward, fast forward, blah, blah, blah. They want us to go ahead and determine the length. Use a protractor to determine the measures of angle A, B, and C. I'm just going to do that up here. A, B, and C. A. Okay, when you're using a protractor, you put the little point on the corner of the vertex. Now, I've lined up, there's a little line. I've lined that up with the bottom of the triangle or this side of the triangle. Now I need to look at where this is hitting, and it looks like it's about 40 degrees. That's angle A, 40 degrees. And then, who remembers what triangles are supposed to add up to inside? 180, so I've got 90 and 40 so far. That's 130. What do we expect this one to be? What else would we add to 130 to make 180? We expect this to be 50, so let's see if it is. Again, the little hole lines up with the B. There's a little line, lines up with the bottom side. And now I look at, oh yes, look at that, right on 50. Okay, so we've got A is 40, B is 50, and C is 90. Measure of angle A. Measure of angle C. Each angle in a triangle corresponds to a specific angle in triangle DEF. Corresponding angles are angles that have the same relative position in corresponding figures. So top corner versus top corner, bottom corner versus the relative position, they match up. What would you predict to be true about the measures of corresponding angles in congruent triangles? Okay. Angle A. First of all, Tony, who does angle A correspond to?
D.
Angle D. They're asking us, what would we predict about the measure of D and the measure of A?
The same.
A, D. Would you predict, Jerry's predicting they're the same. Would you agree with him?
Yeah.
Okay, so that's what they're saying. Same. We predict corresponding angles are going to be the same if we know the two triangles are congruent. Verify your prediction, identify the corresponding angles. So angle A corresponds to angle, angle D. Angle B, who does that correspond to? Is that getting too low? Angle B matches up with angle E, and angle C, who does that correspond to? angle F. Use a protractor to determine the measure of the angles. Do we need to do that?
No.
Okay. Compare the measures of the triangles. In general, what can you conclude? Fast forward. Moving on. All right. Make that a little bigger. Consider triangle JRB and triangle MNS. Where are they? Just pretend that there's some, okay. So, there's, I was looking on the graph, but they're wanting us to think about a triangle in our head. JRB, MNS. Identify the congruent angles. Identify the congruent sides. Okay, the angles are pretty easy. When they name a triangle, they name corresponding parts in the same order. So J corresponds to M, R corresponds to N, and B corresponds to S. So by convention, they line the letters up in the same order that they match. So the first thing they want us to do is angle J and we don't need to see the triangle, oops, R, to know this. We can see what order were the letters in. Angle B. Now, identifying the congruent sides, we can do that in a similar fashion, but I think it'd be a lot easier to draw these triangles. All right, so let's go ahead and make a little JRB. JRB. And identical MNS. And again, corresponding corresponding angle. So now, JR. Who does JR correspond with? Well, if I know J and M match up and R and N match up, it's going to correspond to that side right there. Are you with me? Okay, here's how we write that. JR with a line, congruent to MN with a line. Next one I'm going to look at is RB. Myra, RB is right here. Who does it match on the other side? Or other triangle? NS. Okay. And I notice I used one mark matching one mark, 2 marks matching 2 marks. I'm going to put 1, 2, 3 here. That's, I'm going to call JB. Memo. Who does it match on the other triangle? Thank you. Analyze the 2 triangles shown. Determine the transformation used to create the triangle. Skip that because it did a couple things. It did a rotation thing with it. Does a transformation person write a triangle? Here. What we're going to do now is we're going to write a triangle congruent statement, and we need to look at this carefully. What has happened to this triangle? If this is the starting one, what did they do to get it to here? They rotated it down like this, yes? They took it, and not only did they slide it down, but they slid it down and turned it, all right? So if I look at this, well, the easy one is C. Who does C match up with?
Okay.
Okay, so write a triangle congruent statement. The first thing we're going to do is triangle K and triangle, leave some space, C. Now if I go to this side right here, M, who does that match? W. Okay, so this went whoop, whoop, down. Okay, so in this triangle, M matches W in the other triangle, and the last side then is P on this triangle, matches T on the other triangle. This is a triangle congruent statement, and what I was trying to show you is we carefully found the parts that match up and wrote them in the same order. Identify congruent angles, identify congruent sides. You're going to do right now D and E. I'm going to walk around. D and E, I'm walking around.